Hi everyone, what's up? Welcome back to my tutorial channel. Daniel's here and today I'm making my lesson 4 in the series of probability and SMP preparation. And today's lesson I'll be talking about random variables. So here are the objectives. First of all, I'm going to introduce random variable. Then I'm going to consider the two cases of random variable, the discrete and continuous cases. So let's get started. Random variable. So where's random variable? Let's look at this example. Rolling a die and let x be the number that comes up. So x here can be either 1, 2, 3, 4, 5, or 6. So those are numbers. In this case, x is a random variable. Next example, flipping a coin once, then the outcome can be either head or tail. So here head and tail are not numerical, so the outcome is not a random variable. In short, a random variable is a numerical outcome of a probability experiment. So it's basically just an outcome which is numerical. And a random variable is either discrete or continuous. So now let's consider the first case, discrete random variable. A random variable x is said to be discrete and have discrete distribution if their possible values can be listed. The list can be infinite. For example, the list of all whole numbers. Example, consider tossing a coin once and let x be a random variable that takes two values. X is 1 means the outcome is head and 0 means the outcome is tail. So in this case, x here is a discrete random variable because its values can be listed. We have only two possible values, 1 and 0. Example 2. Consider throwing a die twice and let y be the sum of numbers that come up. So y can be either 2, 3, 4, 5, so on to 36. So the minimum is 2 and the maximum is 36. For example, the first time you got 1, the second time you got 1, then the sum is 2. If the first time you got 6, the second time you got 6, then the sum is 36. So there are 35 possible values of y. Here we have y as a discrete random variable because the possible value of y can be listed. Next, in discrete random variable, to calculate the probability, we need to consider a function which is probability mass function. So the probability mass function PMF of a discrete random variable is usually denoted by P of x, or F with subscript capital X of x, or probability of x equal to x. And this probability is equal to the probability that the value x occurs and it satisfies two properties. The first property is the PMF at any point, any possible value of x is between 0 and 1, and all of the probability should add up to be 1. For example, the table here presents the probability distribution for the number of boys in a family of 5 children, using the assumption that boys and girls are equally likely and that births are independent events. So here's the table, and on the table we see that the probability a family can have either no boy, 1 boy, 2 boys, 3 boys, 4 boys, 5 boys, and the probability is listed in the second column. So any value of the probability should be between 0 and 1, and these probability add up to be 1. The sum is 1. Another tool to work on discrete random variable is probability histogram. So here's a histogram. Following is a probability histogram for the number of children a woman has. The numbers on the tops of the rectangles are the highest. For example, the rectangle of 1, that means the probability of having 1 children is 0.16. The probability of having 7 children is 0.011. So the probability, suppose the question asks you for the probability of a randomly chosen woman has 2 children. So the probability is 0.244. The probability that a randomly chosen woman has fewer than 2 children. So fewer than 2, that means either 0 or 1. So we add these two rectangles together. We have 0.273 plus 0.160, which is 0.433. The probability that a randomly chosen woman has either 4 or 5 children. Either 4 or 5, so we add the values on the tops of the two rectangles, 0.082 and 0.039. So the answer is 0.121. So that is about discrete random variable. Now we consider the second case. So continuous random variable is opposite to discrete random variables. Discrete random variables, the value can be listed, but continuous random values, the possible values cannot be listed. So definition, a continuous random variable is the value that can take values from an interval of real numbers, or perhaps the whole set of real numbers. For example, the waiting time of a passenger until the next arriving bus is a continuous random variable. So for example, you go to a bus stop and you know that every 15 minutes there would be a bus coming. So how long should you wait from the time you arrive the bus stop till the time the bus arrives? So that is an example of continuous random variable. And to work on the probability of continuous random variables, we consider a function that is probability density function, density distribution function, PDF. So it's different from discrete. Discrete we use mass distribution function, PMF, but for continuous we use PDF. Our continuous random variable is denoted by f of x. In discrete case, it's denoted by p of x. And f with subscript capital X of x, which is a continuous function satisfying two properties. The first property is the PDF of any possible value should be greater or equal to 0, and the integral from the infinity to infinity is 1. Here, one thing you really need to pay attention for discrete case, the probability at any single point is 0. Because it's just like one single point, there's no volume. Continuous random variables basically working with volume. So the volume at only one single point is 0. So pay attention. Probability of x at any single point in continuous cases is 0 for any x. Now we work with the second important function in continuous random variable, the CDF, probability cumulative distribution function. So this function is basically just the integrals over an interval. So it's denoted by capital F with subscript x of x, and that is probability of x less than or equal to x. And to calculate this probability, we take integration. We integrate from the infinity to x of function f of z dz. This is basic knowledge in calculus. And for example, if we want to find the probability that here it should be capital X. So probability of A less than or equal to capital X, this is capital X, less than or equal to B is the integral from A to B of f of capital X of x dx. And that is the CDF at the point B, subtract the CDF at the point A. And notice that one thing you should notice here, for continuous, because at any single point the probability is 0, so the equal, less than or equal, and the strictly less than, they are not different. So probability A less than or equal to X less than or equal to B is the same as probability that A strictly less than X less than or equal to B, the same as probability of A less than X less than B, the same as probability of A less than or equal to X less than B. For example, suppose that a continuous random variable X has a density function f of x that is equal to 3 minus 48x squared, when where x is between 0.25 to 0.25. Find the probability that x falls between the closed interval 1/2 to 5/16. So for this is a continuous case because the possible value of x cannot be listed. It's any number from 0.25 to 0.25. So to find this probability, we follow this formula. Basically, we integrate. So we integrate from, here's one thing you need to pay attention. The lower bound here is 1/2, which is between 0.25 to 0.25, so we use 1/2 for the lower bound. And the upper bound, 5/16, is outside the range. So we have to use the maximum value of x here, which is 0.25, because for sure, x less than 5/16. So we integrate from 1/2 to 0.25, not 5/16. And 3 antiderivative of 3 is 3x. Antiderivative of 48x squared is 16x cubed. And we calculate from 1/8 to 0.25, so the answer is 0.15625. So that's how you calculate the probability in continuous random variable. Now, so that's everything for lesson 4. So now we are going to have some practice. And one thing I want you to know, because lesson 4 is still quite easy, so on the exam, on the actual exam, the majority of the question will not fall too many questions in lesson 4. There might be 1 or 2 questions that is from lesson 4. The majority of questions in the actual exam falls from lesson 6 to lesson 11. So in the first few videos, I'm gonna go very quickly, one video, one lesson, and then when I go to the difficult part, I'm gonna break it into a few videos to make sure I give you the better practice for the exam, the actual exam. So now let's look at problem number 1. Let x be a discrete random variable with probability function. Probability of x at a single point x is 2/3 to the x. And the value of x here is 1, 2, 3. So the value can be listed. You see that 1, 2, 3. So find the probability that x is even. Here we have 5 choices. The question asks for the probability that x is even. So x is even, so x can be either 2, 4, 6, 8, 10. Basically, the general form of an even number is 2k, where k is an integer. So the probability that x is even is the summation from k from 1 to infinity of probability of x equal to 2k, because we take only even numbers. And this equal to, using the formula, so for any single point, probability of x equal to 2k is 2/3 to the 2k. So to work on this summation, we need to recall 2 series formulas. The first one is 1 plus q squared plus is 1/1 minus q, and q plus q squared plus to this is equal to q over 1 minus q for 0 less than q less than 1. So here you're gonna take number 2 out, and 3 to the power 2k is 9 to the k. So basically it's summation of 1 over k to the power 1 over 9 to the power k, 9 to the k. So 9 here is q, and we are going to use the second formulas because we start with 9. We start with q, not 1. So this formula is 2's from here, and then we need q, so q there is 9, and 1 minus q is 1 minus 9. So the numerator is 9 and the denominator is 9, and the answer is 4. This question is very easy. So that's the first problem. Let's look at the second problem. In modeling the number of claims filed by individual under an automobile policy during a 3-year period, an actuary makes the simplifying assumption that for all integers n greater or equal to 0, p n plus 1 is equal to 1/5 of pn, where pn represents the probability that the policyholder files n claims during the period. For example, p0 means no claim, p1 means 1 claim, p10 means 10 claims. So under this assumption, what is the probability that a policyholder files more than 1 claim during the period? So more than 1 claim, that means either 2, 3, 4, 5, or 6. And here, because one thing you notice that the list of number is infinite. So if you add up the probability from 2 to 3 to 4, it's gonna be a long word. So for this question, we are going to use complement rule. So probability that a policyholder files more than 1 claim is 1 minus probability that the policyholder files either 0 or 1 claim. And here one thing that is there's an obstacle here, because we don't know the probability at any point. We should know a successive iterate. So there's an iteration here. So we are going to use this iteration to find the probability at any single point. So remember, all the probability add up to be 1. So we are going to use that property to find the probability at any single point. So summation of pi is 1. That means p0 plus p1 plus p3 plus p2 plus p3 and dot so on is 1. And don't forget, p0 is p0, but p1 is 1/5 of p0. p2 is 1/5 of p1, and p1 is 1/5 of p0, so that's 1/5 square of p0, and so on. So from here, we are going to have a geometric series, and with the coefficient is p0, p0. So we are going to factor p0 out, and we will be able to use the geometric series formula right here. So in lesson 4, you are going to use a lot of this series, and also in chapter in lesson 5 or 6, you're gonna have to use this series, geometric series, a lot. So try to memorize this series. So here, if we factor p0 out, we have 1 plus 1/5 plus 1/5 square, 1/5 square plus 1/5 cube plus dot dot dot. So using this formula, with q is 1/5, we have 1 over 1 minus 1/5. So p0 times 1 over 4/5 is 5 over 4 p0, and this is 1. So from here we have p0 is 4/5. So since we have the initial point p0, we will be able to find any probability at any single point. So now the probability that a policyholder files one claim or less during the period is P0 plus P1. P0 is 4/5, and P1 is 4/5 times 1/5 is 4/25. So the sum of these two is 0.96. So using complement rule, the probability that a policyholder files more than one claims is 1 subtract 0.96, which is 0.04. So the answer is A. So now we go to problem number 3. The loss due to a fire in a commercial building is modeled by a random variable x with density function. F of x is either 0.005 times 20 minus x for x between 0 and 20 or 0 otherwise. Given that a fire loss exists 8, what is the probability that it exists 16? So here this is a question of conditional probability. Remember in lesson number 3 we learned about conditional probability. So probability of event A given event B is probability of event A and event B over probability of event B. So here probability that x greater or equal to 16 given x is greater or equal to 8 is probability that x is greater or equal to 16 and x is greater or equal to 8 over probability that x is greater or equal to 8. So on the numerator is just simply x is greater or equal to 16 because 1 is greater or equal to 16 is also greater or equal to 8. So now we are going to use integration to calculate the probability because this is continuous random variables. So on the numerator, we integrate from 16 to 20 using the PDF. And for the denominator, we integrate from 8 to 16. And the answer is 1/9. So to be more specific, I include here how to calculate the probability in details. For the first probability, we integrate from 16 to 20. So 20, the antiderivative is 20x. The antiderivative of x is x squared over 2, and we consider from 16 to 20. So the answer is 0.04 for the first integral. For the second integral, we integrate from 8 to 20. So similar, but the only difference is we consider different intervals. So 1 minus 0.64 is 0.36, and then we bring the 2 to the top, and we have 0.04 over 0.36, which is 1/9. So 1/9 is the answer. Now we consider problem number 4. The lifetime of a machine part has a continuous distribution on the interval from 0 to 40, with the probability density function is proportional to 10 plus x to the negative 2. Where is the probability that the lifetime of a machine part is less than 6? So here, between 0 and 40, we have infinite possible values, so this is continuous. So to find the probability that the lifetime of machine part is less than 6, we basically just integrate from negative infinity to 6. But here, the interval, the minimum value is 0, so we are going to integrate from 0 to 6. So solution. However, one thing you need to pay attention here is the function is not given. The function is not given. So we are going to find the formula of the function first. The question only gives you one piece of information. That is, the probability density function is proportional to 10 plus x to the negative 2. So this is not the density function. So we are called the general formulas for the PDF is a times 10 plus x to the negative 2 because it's proportional to 10 plus x to the negative 2. So the first job is we are going to find A. Using the property that the integral over the interval of the PDF is 1. So 1 is integrate from 0 to 40 of A times 10 plus x to the negative 2. And this is 8 this is a over negative 1 times 10 plus x to the negative 1. Consider from 0 to 40. And this integral is equal to 2a over 25. So basically 1 is equal to 2a over 25. From here, we are able to find a is 25 over 2. One more thing I want you to know, on the exam, usually you are going to see a lot of questions that the density function is not given, but just like proportional, or like this question will be seen on the exam very useful, very often. Like the question where the PDF is not given, but you're proportional to a function. So that the first step we have finished. So we finished finding a. Now we use a. The problem now becomes very easy. We basically should integrate from 0 to 6 using this PDF function. So the probability that the lifetime of the machine part is less than 6 is integrate from 0 to 6 of 25 over 2 10 plus x to the negative 2 dx. And this equal to negative 25 over 2 10 plus x to the negative 1. Consider from 0 to 6. So the answer is 0.46875. And route it to 2 decimal places, we have 0.47. So answer C. So that's problem number 4. I repeat one more time. Like on the exam, you are going to see the question where the density function is not given very often. Like usually the question will just give you a piece of information like it's proportional to a function. So keep that in mind. The first job is to find the leading coefficient right here. So A here is the leading coefficient. Next, problem number 5. Let x1, x2, x3 be 3 independent identically distributed random variables as with density function f of x. F of x here can be either 3x squared or 0. 3x squared from 0 to 1 and 0 otherwise. Let y be the maximum of x1, x2, and x3. Find the probability that y is greater than 1/2. So for the question working with maximum and minimum, here's a tip. Usually like the max of these 3 variables to be greater than 1/2, then either one of these 3 should be greater than 1/2. And if you work by that direction, you are going to deal with OR events. And it's not a good choice to work with OR events. Usually we try to manipulate the problem to work with AND event, not OR. So here, if you modify this a little bit, probability of y strictly greater than 1/2 is 1 subtract probability of y less than or equal to 1/2. The problem would be easier because when the max is less than 1/2, all of these 3 should be less than or equal to 1/2. And we are going to use independent properties, so the problem becomes easier. So here we first use complement rule. Probability that y is strictly greater than 1/2 is 1 subtract probability that y is less than or equal to 1/2. So y is the maximum. The maximum is less than 1/2. That means any number x1, x2, and x3 should be less than or equal to 1/2. So the probability x1 less than or equal to 1/2, and x2 less than or equal to 1/2, and x3 less than or equal to 1/2. And here we are going to use independent events. So basically we multiply its individual together. So 1 subtract probability x1 less than or equal to 1/2 times probability x2 less than or equal to 1/2 times probability that x3 less than or equal to 1/2. And one more thing to pay attention here, x1, x2, x3 are identical distributors. So probability that x1 less than or equal to 1/2 is the same as probability that x2 less than or equal to 1/2 and less than or equal to probability of xq less than or equal to 1/2. So and for each of these, we integrate from 0 to 1/2 of 3x squared dx. So the answer is 1/2 for each of these 3. So now we are able to find the answer. So probability that y is strictly greater than 1/2 is 1 minus 1/8 cube. So the answer is 511 over 512. So answer E. Answer E. So that's it. Thank you so much for watching, and I hope you guys have a great night. Um, please follow me for the next video. The next lesson I will be talking about expected expected value and some distribution properties. Thank you so much, and bye bye.